The application is alive. 2 copies of it sit inside a Kubernetes cluster, each wrapped in a pod, each answering on its own private address. From the inside, everything looks healthy. From the outside, nothing answers. That is the quiet failure this story is about. A cluster is a sealed machine room. Pods come and go. Their IP addresses change when they restart. A browser on your laptop has no map of that room and no key to the door. You can have a perfect web server and still serve nobody. The question is not whether the software works. The question is whether anyone beyond the cluster fence can reach it. Kubernetes answers that with a service, a stable doorway in front of unstable pods. But not every doorway opens to the street. Some stay inside the building. Some punch a hole through every wall. Tonight we follow the hole that punches through, NodePort. Before that name means anything, feel the stakes. If there is no path from a node's public face to the process listening in a pod, the cluster is a museum of running processes. Beautiful, useless. So what kind of door do you want? One that keeps the world out, or one that lets a stranger knock on every machine? A Kubernetes service is not the application. It is the agreement that the application can be found. Pods are temporary. They die when a node fails. They multiply when you ask for more replicas. Their addresses are not a contract you can print on a business card. A service is that contract. It gives you a stable name and a stable way to send traffic. Then it watches a set of pods and forwards packets to whoever currently matches. The source puts it plainly. Services exist so pods can be exposed, and so pods can reach one another even as the cast of pods changes. Think of a hotel front desk. Guests move rooms. The desk number does not. When someone calls the desk, a clerk routes the call to the room that is occupied tonight. That clerk is the service. Without it, every caller would need a live inventory of rooms, and the inventory would be wrong by morning. With it, the cluster can replace a pod and the caller never learns the old address died. This is service discovery in the most practical sense. Not a philosophy, a forwarding rule with a name. And once you have a named doorway, you must decide who is allowed to walk through it. That decision is the service type. It is the first real fork in the story. The default doorway is cluster IP. The name is almost a warning. Cluster, then IP. An address that lives only inside the cluster. Other pods can call it. Jobs inside the same private network can call it. A laptop on the public internet cannot. That is not a bug, it is the design. Databases, internal APIs, the quiet machinery that should never face a stranger, those belong behind cluster IP. The source is blunt. Cluster IP exposes a service on an internal IP, reachable within the cluster, used for internal purposes. If you did not want the pod outside, this is the type you choose. Picture a factory with an excellent intercom. Every workshop can call every other workshop. The street outside has no intercom handset. Your Nginx welcome page could be serving beautifully on that intercom, and a user at a cafe would still see a timeout. Containment is a virtue until the product is a website. Then containment becomes the entire problem. Cluster IP wins on safety and simplicity. It loses the moment the stakeholder is a human with a browser. The application works perfectly. The user is still outside. So the next idea is almost rude in its simplicity. What if every machine in the factory grew a doorbell? Kubernetes does not offer one doorway. It offers a small family of them, and they disagree about intelligence versus reach. Cluster IP, as we said, stays inside. NodePort opens a port on every node so the outside can come in. Load balancer sits at the transport level. It often sprays TCP connections in a round robin, treating packets as cargo rather than as pages and paths. Ingress lives one layer higher. It reads content. It can send this host name to that service, this path to another, and make more intelligent load balancing decisions. The sources comparison is almost a character study. Load balancer is a traffic cop at an intersection who counts cars. Ingress is a concierge who reads the invitation. For this story, we stay with NodePort because it is the first type that actually answers the opening crisis, a user beyond the fence. But keep the rivals in the room. NodePort will solve reachability in a blunt way. Later, when the port on every node starts to feel like leaving every window unlocked, those rivals will look less like extras and more like the next chapter. For now, the brief is simple. We need a door that faces the street. NodePort is that door. NodePort is a service that exposes the nodes themselves and the applications running on them to the outside of the cluster. That sentence from the source is doing a lot of work. It does not say it exposes one special machine. It says the nodes, plural. The same assigned port appears on each node's IP. Traffic that arrives on that port is claimed by the service and sent onward to a matching pod, which may or may not live on the node that received the packet. That last part is easy to miss and essential. You are not required to guess which worker holds the container. You knock on any worker that has a public face on the published port, and the cluster's forwarding does the rest. Users reach the application with a node IP address and a port. Not a pod IP, not a guess, a pair you can write down. Internally, the service still behaves like a service. Other workloads inside the cluster can still talk to it. NodePort does not cancel cluster IP's inner life. It extends it. Containment plus a hole. The hole is the point. The hole is also the cost. Before we celebrate, we have to know which numbers that hole is allowed to use, and what the nodes must already own for the trick to work at all. Kubernetes does not let NodePort pick any number it likes. The external port lives in a reserved band, 30,000 through 32,767. That is 3,268 possible doorbells, high enough that they rarely collide with ordinary system services. You may specify the number yourself, as the sample YAML does with 30000, or you may let the control plane assign one at random inside the band. Either way, the contract is the same. That number is opened on every node. Here is the catch the source will not let you skip. The nodes need public IP addresses if the user is truly on the internet. A doorbell on a private hallway is still a private doorbell. In a laptop lab with Minikube, public may mean reachable from your own machine. In a real fleet, it means the node IP you publish is an address the client can route to. If it cannot, NodePort has done its job inside the cluster and still failed the user. So two constraints travel together: a port from that high range, a node address the outside can actually dial. Miss either one and the elegant diagram becomes a closed room again. The range is not trivia. It is the legal street number of the door we are about to open. Watch the path, because this is the whole mechanism. An external user aims a request at a node IP and the node port. The packet lands on a host. It does not have to land on the host that happens to run the pod. From that host, Kubernetes hands the traffic to the service object. The service is the stable middle. It knows, through a selector, which pods currently belong to this application. It forwards to one of them on the port where that pod is actually listening. The pod answers. The reply travels back along the same logical path. 3 actors in that order: node face, service, pod. If you remember only one picture, remember that chain. Opening a door is not enough. The door must know which room is occupied. That is why a node port without a working selector is a doorbell wired to an empty house. That is why 2 replicas matter later. The service has more than one legal room. The source's diagram draws several hosts, each wearing the same external port, a service in the center, and pods inside the cluster box. Traffic arrows come from outside. The hosts are interchangeable entrances. The service is not optional decoration. It is the switchboard. Keep that picture. We are about to put real field names on each hop. Here is the first sample, translated into the language of the door. The document is a service. Its type is NodePort. That single field is the decision to face the street. Under ports, 3 numbers share a line of work. Port 80 is the port the service itself exposes inside the cluster. Other cluster citizens talk to the service on 80. Target port 8080 is the port on the pods, the socket the container actually bound. Node port 30000 is the number punched through each node's public face. The selector says app equals example-app. Only pods wearing that label are eligible destinations. Change the type to cluster IP and the node port line becomes meaningless. Change the selector and you have a perfect door into the wrong apartment. The metadata name is how humans and kubectl will refer to this object. None of this edits the application image. The pods keep listening where they always listened. The service is a layer of addresses wrapped around them. That is why the opening crisis can be solved without rewriting the app. You did not make the process more public. You published a path to it. The YAML is the path, written as data. Read it as a story of 3 ports and 1 label, not as a pile of punctuation. The second sample looks almost identical, and then it isn't. Port 80. Target port 80. Same number, different jobs. The source pauses here on purpose. The major difference, it says, is this. Port is where the service exposes the pod, and target port is where the pod listens. They may match, they often do, because humans like symmetry. They are allowed to differ, as they did in the first example, when the service speaks 80 and the container speaks 8080. Confusing them is the most expensive small mistake in this entire subject. If you set target port to a socket the container never opened, the service will happily accept traffic and then deliver it into silence. The door works, the room is empty. In the later hands-on, the numbers flip again. The expose command will use port 8080 and target port 80, because Nginx in the official image listens on 80, while the service is being offered on 8080. 3 scenes, 3 pairings, 1 rule. Port is the service's face. Target port is the pod's ear. NodePort, when present, is the city's street number. Say those 3 sentences until they bore you. Boredom here is competence. The YAML will keep changing costumes. The jobs will not. A service does not point at a pod by name the way a sticky note points at a desk. It points at a label query. App equals example-app. App equals my-app. Whatever key and value you choose, the service continuously evaluates which pods wear that badge. New replica appears with the badge, it joins the pool. Old replica dies, it leaves. You never edit the service to chase a new pod IP. That is the whole point of the clerk at the front desk. If the badge is wrong, the clerk has an empty book. If 2 unrelated apps accidentally share the badge, the clerk starts handing calls to the wrong guests. Labels look like metadata fluff. They are the wiring. In the first YAML, the selector is example-app. In the second, it is my-app. In the demo we are about to run, the deployment named nginx will typically stamp its pods with a label derived from that name, and the expose command will build a service that selects those pods. You should still look. A service that exists and a service that selects are not the same object. Existence is kubectl saying created. Selection is traffic actually arriving. When something is exposed and still times out, the first suspect is not NodePort. It is a selector that matches nothing. The doorbell again on an empty house. The NodePort field is optional in the file and mandatory in the world. If you write 30000, you are claiming that exact street number on every node. If you omit it, Kubernetes picks one from the legal range and writes it back into the live object. Either way, after the service exists, that number is real. It is what a user puts after the colon. It is what a firewall must allow. It is what you must not casually reuse for a second service on the same cluster, because the port is a cluster-wide resource on the node network, not a private decoration inside one namespace's imagination. The first sample chooses 30000, the bottom of the band. Easy to remember, easy to collide with the next tutorial that makes the same cute choice. The diagram you may have seen labels hosts with 30003. That is not a contradiction you need to resolve as a bug. It is an illustration that any value in the band can appear on the hosts. The text's example and the picture's example are both legal doorbells. What matters is sameness across nodes, not a superstition about one lucky number. Pick it or accept the random one, then treat it as part of the public contract. Users will bookmark it, firewalls will ossify around it. That is the static port the comparison table will later call out as NodePort's signature. Imagine 3 hosts in a line. Each wears the same external port, call it 30003, as the diagram does, or 30000 as the YAML does. It is the same idea. Arrows of traffic approach from the left, indifferent to which host they strike. Inside a box labeled the Kubernetes cluster, a service sits in the middle like a roundabout. Beyond it, several pods. The picture is almost childlike, and that is its strength. You can see that the hosts are not the application. You can see that the service is not a pod. You can see that many pods can sit behind one service. You can see that traffic is allowed to enter through any host. What the still picture cannot show, and what you should now animate in your head, is failure. Kill one pod, the arrows still work. Drain one host. If another host is reachable, the arrows still work. The architecture is built for that shrug. NodePort's gift is not performance. It is a uniform face on a shifting interior. The cost of that uniformity is visibility. Every host now advertises the same open port. In a small lab, that feels like convenience. In a hardened network, it is a surface you must justify. Hold both truths. We have enough theory. The next chapter asks a ruder question. Can we prove it, not merely diagram it? The demonstration chooses Nginx version 1.23 and asks for 2 replicas, not 1, 2, so the service has a pair of legal destinations and the idea of selection is not a fiction. The command is a single line with a lot of intent. kubectl create deploy image Nginx 1.23 name Nginx replicas 2. That creates a deployment, which is a controller. The controller's job is to keep 2 pods alive that run that image. You are not yet exposing anything. You are only stocking the rooms. If this step fails, every later step is theater. If it succeeds, you still cannot browse the welcome page from outside, because we have built cluster IP's world, processes with private lives. That is deliberate. The source separates create from expose, so you feel the seam. An application can exist in Kubernetes without being a product on the network. Existence is the deployment. Publication is the service. People collapse those words in conversation. The commands refuse to. After this runs, you have 2 Nginx processes, almost certainly listening on port 80 inside their containers, labeled so a future service can find them. They are the cast. They are not yet on stage. The next command is the curtain. Now the doorway. kubectl expose deploy nginx, type NodePort, port 8080, target port 80. In one breath, you create a service in front of the deployment's pods, declare that the service's own port is 8080, and declare that the pods listen on 80. The type is the decision we have been circling since the beginning, NodePort. The source says this exposes the deployment as a NodePort service with the name nginx-service. Notice the numbers against the first YAML. There, the service spoke 80 and the pod spoke 8080. Here, the service speaks 8080 and nginx speaks 80. The jobs did not swap identities, only the costumes did. Target port still means the pod's ear. Port still means the service's face. Because the official nginx image listens on 80, target port 80 is the line that makes the demo true. Get that wrong and you will expose a service that selects the right pods and still serves nothing. Type, port, target port. 3 flags, 3 earlier chapters, 1 command. After it returns, the cluster has a new object. The nodes should now be listening on some port in the high range. We have not looked yet. Looking is the next discipline. Creating is not verifying. Optional, the source says, and then shows you why it is not optional in your head. kubectl get svc nginx-service output wide. Wide matters. The default table is polite and incomplete. Wide is where you see the type, the cluster IP that still exists underneath, the port mapping, and often the node port Kubernetes actually bound. This is the moment the abstract range becomes a concrete colon number. You should see node port in the type column. You should see 8080 as the service port. You should see 80 as the target. You should see a node port in the 30000 band, either the one you demanded or the one you were given. If the type is still cluster IP, the expose command did not do what you thought. If the selector is empty, you have a named object with no guests. The source's verdict after this command is simple. We have successfully exposed the service with NodePort. Treat that verdict as a claim to check, not a blessing to skip. The wide listing is the contract printed in monospace. Copy the NodePort. You will need it the moment you leave the comfort of a helper command and try to build the URL yourself. Inspection is how a doorway becomes a number you can trust. Minikube is a cluster that pretends to be a fleet on a laptop. Its nodes are not sitting on a public cloud IP, so the source does not tell you to guess. It gives a helper. Minikube service ngnx-service URL. That command asks Minikube to print the address at which this service is reachable from your machine. The result is a URL, a host and a port, the local incarnation of Node IP plus NodePort. On a real multi-node cluster, you would assemble that pair yourself from a node address and the inspected node port. Here, the tool does the assembly because the node's idea of itself and your laptop's idea of the node are not always the same network story. Either way, the object you hold is the same kind of thing the theory promised. A reachable face, a port in the high band, a path that should now terminate in NGNX. The source's next sentence is almost casual. On invoking this, you can see it in the browser. Casual is the wrong mood. This is the trial. Every YAML field, every flag, every claim about selectors and target ports is about to be judged by a page that either appears or does not. Open the URL. Do not narrate success until the page speaks. Welcome to NGNX. Those 3 words are the verdict. The screenshot in the source is not decoration. It is the only proof that matters in a story about reachability. A process that lived in a sealed cluster is now answering a browser on the machine outside. Nothing about the NGNX image had to change. The deployment did not grow a public IP. The pods did not start advertising themselves. A service of type NodePort converted internal pods into an externally reachable application by publishing a path. The source says this access on your machine to something running in the cluster is only possible because of the NodePort service. Believe that sentence in its narrow sense. Other types can also reach the outside. This demo used this type, and this type is what made this URL work. The page is ordinary. That is the point. Ordinary is what users wanted the whole time, not a lecture on selectors, a welcome page. We opened on a timeout. We closed this chapter on a heading in a default site. The crisis named in the first minute is resolved for this application, on this laptop, through this doorway. What remains is judgment. Was this the right kind of door, or merely the first door that opened? The source ends with a table, and the table is a character contrast, not a spreadsheet. NodePort exposes a static port on each node IP and allows traffic from the internet to reach the pod. Cluster IP exposes the service on an internal IP, reachable only inside the cluster. If you want the pods both outside and inside, NodePort. If you do not want them outside, cluster IP. If the thing is a web application, NodePort is the type the table nominates. If the thing is a database or an internal API, cluster IP is the type it defends. Read that again with the demo in mind. We chose Nginx, a web server, 2 replicas, and NodePort, and a browser answered. Had we been publishing a database, the same success would have been a security incident with a welcome packet. The table is not saying NodePort is better. It is saying the door should match the guest. NodePort's signature is that static external port on every node. Convenient, obvious, a little loud. Cluster IP's signature is refusal. Refusal is a feature. The last line of the article restates the whole film in one breath. NodePort exposes the application outside the cluster. Cluster IP is for internal purpose only. After a welcome page, that line is no longer a definition. It is a choice you now know how to make. A doorway is not a city. NodePort got the stranger to the building. It did not read the stranger's invitation. Load balancer, in the source's telling, works at the transport level. TCP, often round robin. It is a way to hang a cloud provider address in front of a service and spray connections. Useful, not thoughtful. Ingress is described as more intelligent. It can look at content, make finer load balancing decisions, optimize what a load balancer treats as opaque bytes. Host names, paths, the shape of an HTTP request, that is Ingress's home turf. If you are running one demo service on a laptop, NodePort is honest and enough. If you are running many applications, many names, certificates, and policies, a static high port on every node starts to look like a sketch, not an architecture. The rivals we left in the room are now leading forward. NodePort solved the original timeout. It did not solve scale or discretion or the wish that two websites might share one public face and still land in different services. Those wishes are why the family of types exists. Remember them without abandoning what we proved. We needed a street-facing door. We built one. The next design question is whether the street should see every node's port or a single smarter gate. We opened on a living application that nobody could reach. Pods with private addresses, a cluster like a locked machine room, a user with a browser and no map. Cluster IP, the default, would have kept that lock and called it safety. NodePort offered a blunter mercy. Open the same port on every node, take traffic at node IP and node port, hand it to a service, deliver it to pods chosen by a label on the port those pods actually hear. We wrote that path as YAML. We walked it as commands. We watched a default Nginx page appear, which is a small thing and also the entire point. The knowledge made a sealed process into a reachable product without rewriting the process. It also left a surface, a static port, a need for reachable node addresses, a door that does not read the request. So the field's unfinished question is not whether NodePort works. We saw it work. The question is when a more intelligent or managed path should replace this honest hole in the wall. When does the doorbell on every house become the wrong city plan? That is where this story hands you back the keys. Choose the door that matches the guest, and when the guest list grows, be willing to change the door.